absolute value inequalities and equations. We'll start with equations. Absolute value of something is it's a distance from zero, so it's never negative. We are also going to talk about extraneous solutions. Extraneous solutions are solutions that you get in the process of solving a problem, but don't actually work when you plug them back into the original problem. So it's very important that you check your answers on these problems. If the absolute value of x minus 3 must equal 10, then that means x minus 3 can equal two different numbers. Because the absolute value of 10, there's two numbers that can give you that, negative 10 and positive 10. So we've got x minus 3 equals negative 10, and x minus 3 can also equal positive 10. Then we solve, and we're going to add 3. So x equals negative 7, and x can also equal 13. How we check? Okay, plug them in. Negative 7 minus 3, that's the absolute value of negative 10. Check. And then the absolute value of 13 minus 3, which is the absolute value of 10. Check. Example B. This is the type of problem that could give you an extraneous solution. Why can it give you? Because we have an x outside of the absolute values. Alright, 2x plus 5 can either equal 3x or it can equal negative 3x. I'm going to subtract 2x. That's going to give me 5 equals x. Check that one. We're going to get 2 times 5 plus 5. The absolute value of that, does it equal 3 times 5? Okay, well this is 10 plus 5, which is the absolute value of 15. Does that equal 15? It sure does. Okay, that's a good solution. Next one. Now I'm going to add 3x, just because I want to keep it positive, plus add 3x, subtract your 5. It's going to give me 5x equals negative 5. Divide by negative 5, or divide by 5, excuse me. X equals negative 1. Check your answers. Absolute value of 2 times negative 1 plus 5. Is that going to equal 3 times negative 1? Okay. Red flag should be going up right now. This is negative 3. Are you ever going to have an absolute value equation that's going to give you an answer of negative 3? Never. You will never have an absolute value that equals negative 3. So, therefore, negative 1 is an extraneous solution. Properties. Absolute value inequalities are actually compound inequalities, just written shorter. Okay? So they can be converted in between a compound inequality and an absolute value inequality. So that's what we're going to do. Absolute value of ax plus b is less than c is actually an and. Negative c is less than ax plus b is less than c. Okay? The main thing to remember here, if you make this negative, this becomes your lower boundary in your and, so less thans become an and inequality, where this is in the middle, and then positive, negative, this is on either side. With greater thans become an or inequality. Okay? When we rewrite it, we've got the absolute value of ax plus b is greater than c. That means ax plus b must be either greater than c, so just like it was here, or ax plus b is less than the negative of c. Okay? So, still, c becomes it either stays the same, positive C or negative C. Here, this is either going to be this or it's going to be less than that. So you're going to have one where it is a greater than and one where it is a less than, and it's going to be less than the negative. If you think about what kind of numbers will give you an absolute value greater than this, then this must be either greater than C, as it is, or it must be less than the negative of that. Because any number less than the negative of that is going to have an absolute value that's greater than that. I know it's kind of confusing, but I try to make it easy. If you just remember that greater than's become an or, and it's either going to be written as AX plus B is greater than C, or AX plus B is less than the negative of that. Okay, let's solve a couple of these and graph them. Okay, let's start with a greater than. So this is going to become an or, and it's either going to be 3x plus 5 is greater than or equal to 10. 3x plus 5 is greater than or equal to 10, or 3x plus 5 is less than or equal to the negative 10. Now we have two equations to solve, and we solve them. So we subtract 5, so we've got 3x is greater than or equal to 5, divide by 3. So x must be greater than or equal to 5/3, or subtract 5, 3x plus 5, or we subtracted the 5, right? Right. 3x must be less than or equal to negative 15, divide by 3. So x is less than or equal to negative 5. Okay. So when we graph that, it's an or, so we're going to have a big blank space somewhere in the middle. Negative 5, it's an or equals 2, so a dot. Numbers less than negative 5, okay. Let's see, here's 0. 5/3 is 2 2/3, so there's 1, not 2 2/3, silly me. 1 2/3, there's 2. So 5/3 would be right about there. Put it on there. Greater than or that. Next one is a less than. Since it's a less than, we're just going to start with the negative of that. Negative 6 less than x plus 2 is less than positive 6. And then we solve. Subtract 2 from everywhere. Negative 8 is less than x is less than 4. Graph. Just like the x is between these two, we're going to have negative 8. We'll say there's 0, there's 4. It's just less thans, so circles, and we shade in between them. The food manufacturer specifies that every family-sized box of cereal should have a net weight of 25 ounces. It says, with a tolerance of 1.2 ounces. What's tolerance? That's an acceptable difference. Write and solve an absolute value inequality that describes the acceptable net weight. Okay? So for a verbal model, we want an acceptable difference of 1.2. So that means that it can go either way. We can be 1.2 less, or we can be 1.2 higher. Either way. So what we want is we want for the absolute value of our actual weight minus our tolerance, or minus our ideal weight, sorry, to be less than or equal to the tolerance. Okay, there's an example of a verbal model. So if our actual weight is W, and our ideal weight is our 25 ounces, we want that to be less than or equal to our tolerance of 1.2. Okay, now we're going to solve. Now to solve an absolute value inequality, we convert it to its compound version. This is nice. Everybody gets the less thans much easier than the greater thans, because now our tolerance can, like I said, go either way. It can either be 1.2 higher or 1.2 less. So negative 1.2 less than or equal to W minus 25 less than or equal to positive 1.2. So, what is our range of acceptable weights? Add 25. We get 23.8 less than or equal to W is less than or equal to 26.2. So, in our terms of our problem, an acceptable weight, net weight for the food of cereal, family size, blah, 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 23.8 for the lowest amount and 26.2 for the highest. Okay, now anytime you're manufacturing anything, there is a tolerance, there is an acceptable difference, and depending on what your position is or what your job is, they'll let you know how close you can be. Excuse me. Alright, another problem. This time we're kind of working in reverse. Okay, you have found that your new winter coat is comfortable to wear out when the temperatures are between 10 degrees Fahrenheit and 42 degrees Fahrenheit. Inclusive, meaning including those degrees. Write an absolute value inequality for this range where T is the temperature in degrees Fahrenheit. Alright, here's something we got to do. Here is the compound inequality using the information we're given. To do an absolute value inequality, we've got to work in reverse. So we've got to actually calculate the tolerance. For that information, what is the tolerance? So to calculate the tolerance, we find the mean of the extremes. Find the average of the extremes. Find the average of your lowest and your highest. Those are your extremes. And then subtract that from the upper extreme, and that is your tolerance. So, we're going to take 10 plus 42 divided by 2, which is 52 divided by 2, which is 26. So 26 is the mean of our extremes. We're going to subtract it from the upper extreme, and our tolerance is going to be 42 minus 26 is 16. So this is our 16 degrees is our tolerance. Okay. So now if we were to write a verbal model, many of you want to jump right to the equations, so sometimes it's easier to write a verbal model. Now, to write an absolute value inequality, it's going to be just like what we did before. We're going to have our actual, in this case, temperature, minus the average of the, minus the mean of the extremes. Let me use the terms we use. The mean of the extremes. And this is going to be less than or equal to the tolerance. Okay? So, our actual temperature is going to be T. We've got our mean of our extremes. We've got our tolerance. Now we just plug those in. So we've got T minus 26 must be greater than or less than or equal to 16. Okay. Homework. Classwork. Whatever. Page 53, 4 through 40. EOE means every other even.